Okay. Guys, we're starting, so zip your lips. On number 1, so it's just a multiply problem. So 6 times -3 is -18. Are you guys on the page already?
Yeah. No. We're gonna need graph paper, I think.
366, 1 through 40. Not today, we won't.
Oh.
This is a 2-day, it's 1 through 40, a 2-day assignment due on Friday. Okay, 1, so 6 times -3. What's n squared times m? N to the third, right. Just add the exponents. What's n 5 times n 7? N 12, correct. That's number 1. They didn't say it on the directions, but what they wanted for this section was no negative exponents. No negative exponents for this section. There's not going to be a lot, but there's a couple. Okay, number 3 is dividing. So 81 divided by 9 is 9. And then what's A4 divided by A? A cubed. Remember division? 81 divided by 9 is 9.
What about the 4 thing?
A4 divided by A. Remember how to do division? Subtract. 4 minus 1.
This isn't due tomorrow, right?
Due Friday. B3 divided by B.
B squared.
B2, right? B squared. Okay, C2 divided by C2.
0.
C to 0, which is 1, which just disappears. Okay. C's go away. Number 5. Maybe you should go around the room. Does anyone want to start?
No, please don't do this to us. Don't.
Maybe you should start.
Olivia should start.
No.
Olivia, you can do it.
No,
I
stop.
5's not too bad. You can do it. So, okay, Olivia, 8 divided by 2.
4.
And then M4 divided by M2. M2. And then N2 divided by N.
Just
Just an N. And then P5 divided by P.
P4.
P4. Okay, by the way, while I'm thinking about this one, number 4, when you multiply 2 fractions together, the top gets multiplied together, like top times top. 4W7 times Z3 is just 4W7 Z3. And then the bottom gets multiplied together. So number 4 really is pretty much the same thing as number 5. Because the tops just go together and the bottoms just go together. Does that make sense?
Not
So everything on top gets multiplied together, so it's like one big fraction basically. And everything on bottom gets multiplied together. So just like on number 5, you do the top divided by the bottom. 4 divided by 2, W7 divided by W2, Z3 divided by Z. Just like 5. Okay, number 7, Willow. What happens when you do Y2 divided by Y2?
It just goes away.
It goes away. And then there's also an x to -3 on the bottom, but where you don't want negative exponents.
So you just take off the negative and keep it on the bottom?
Nope.
Oh, would you flip it?
Flip it. So x -3 on the bottom is x to the third on the top. And because everything else went away, it's just x to the third. Okay, number 9. Okay, actually, before we do 9, let's talk about this really quick, because this confuses most people when they first see it. What's 2 to the third times 2 to the fourth?
7.
Okay, why is it not 4 to the seventh? Okay, because this is telling us to multiply 2 together 7 times. So if you already multiplied 2 of the 2's together, yeah, it's going to screw it up. It's not 4 to the 6th either. It's not 4 to the... If you change it to a 4, that's going to mess everything up. So we're not solving it, we're just leaving it as 7 2's multiplied together. We're not multiplying any of the 2's together, just leaving it alone. Okay, anyways, hopefully that helped a little bit, I don't know. So, Paxton, on number 9, what do we need to do with those exponents?
What are you gonna do?
Yes.
I mean, like, gotta like, freaking x minus 5.
Are we, when you do 2 times 2, do we add, subtract, multiply, divide? What do we do with the exponents here?
You add.
Add. So what is 5 plus x minus 5?
0.
5 plus x minus 5.
Is, changes to what? What happens here?
X minus 5.
Well, you can add your like terms, right? So what's 5 minus 5?
Oh, 0.
0. So we're just left with x. Is the answer x?
No.
No, what's the answer?
2x.
2 to the x.
Oh yeah. Bananas.
I knew that.
Okay, number 11. That was kind of a weird one. We did one like it way back in the homework. Okay, number 10, I'm not going to do it with you, but I will say this. 10 is different because it's adding and subtracting terms, not multiplying and dividing. So what you need to do is simplify each term, and if you have any like terms, you can add or subtract them together. So for example, the first term, 2j negative 2 k4 j5, what is j negative 2 times j5? What's j negative 2 times j to the 5th? We can simplify it. J3. So the first term becomes 2 j3 k4. If any of the other terms turn into j3 k4s, you can add and subtract those terms. I guess on this one maybe you can subtract those terms. But that's how number 11 starts. That's the first term. First 10, not 11. Okay, 11 is kind of the same thing, but it says leave all variables in the numerator. In other words, if we get like a to the negative 2, we're going to leave it as a to the negative 2. We're not going to flip it. Forrest, what should we do with the negative 3?
I thought we were gonna do in first.
No, numbers usually go in front.
Just put it there, just negative 3.
Yeah, we're going to do nothing with the negative 3.
Oh, okay.
And then what's m negative 3 divided by m?
It's n negative 4.
Right. So basically, my word. It's negative 3 minus 1. This does confuse people a lot. So it is negative 4. It's negative 3 minus 1. So it's negative 4. On this section, we are not flipping on 11 through 13. So we're just going to leave that. Okay, and then what are we going to do with the R7?
It's R5. R5. Right?
Yeah, R7 divided by R2 is R5. Just subtracting here. And S's, so that would be negative 4 minus 2 is
Negative 6.
negative 6. If you get confused, you might want to write it out. Like negative 4 minus 2. And if that confuses you, plug in the calculator, make sure you get it right. Because usually when we start doing minuses and negatives, people start getting these confused.
Where did you get whenever you did negative 3 minus 1, where did you get the 1 from?
It was invisible. If there's no exponent on the m,
It was from the bottom?
yes. Okay, number 13, Grant. Let's see where we're at. What do you think we should do first on 13, Grant?
On 13,
Yeah.
we should simplify the top and the bottom. Maybe.
Um,
Oh, wait.
well, in order of operations, what comes first? Exponents or multiply?
Exponent.
Exponent. So that right parentheses has an exponent we can use. So we probably should do the right parentheses first. So, Grant, I see a negative in that parentheses. What happens when you square a negative?
It like becomes positive.
Becomes positive. So basically that negative is just going to disappear. So just forget about it, don't worry about it. And then what's on the top, we have y squared, so that's gonna be y squared. And then on the bottom, we have 2 squared, which becomes what?
4.
4. And then we also have, you guys see where I'm looking in the parentheses?
Yeah.
We also have x cubed squared.
Would be like x to the 6.
Okay, so that's the parentheses stuff right there. And then over on the left side, we have -3. Oh, no, am I looking in the right place? Yeah, I am. X squared, 1 -3. Need more space. Darn it. Alright, whatever. Over x. Okay, so let's start with the normal numbers. Do you guys remember what I said on number 7 or number 4? When you have fractions multiplied together, basically the top all just gets multiplied together, so it's like one big fraction, and the bottom all gets multiplied together. So just think of it as all one big thing, basically. Okay, I see a -3 on top and a 4 on bottom. So Grant, what are we gonna do with that?
You flip it.
Nope, no negative exponents, it's just
Oh.
-3 over 4.
Sorry.
Okay, now normally I extend that bar and then just put the letters on top or bottom. But on this section it said no negative exponents, everything's just gonna go on top. It didn't say no negative exponents, it said everything in the numerator, that's what I meant. Okay, then for my x's, I see 2 on top and an x -1, x6 on bottom. So Grant, what is x -1 times x to the 6th on the bottom?
X to the 5th.
X to the 5th, yeah, you just add those together. And then what's x squared over x to the 5th?
X to the -3rd.
Correct. So that's our x's. I did put the ones on bottom together, -1 plus 6 is 5. And we had 2 on top,
Yeah.
so basically it was 2 minus 5. -3. And then Grant, for the y's, we have y -3, y2 on top. What would that become?
Y -1.
Right, -3 plus 2 is -1. And then we have 1 on the bottom,
So it would be -2.
right, -1 minus 1 is -2. I think we got everything, didn't we?
Yeah.
Got the numbers, the x's, the y's, check, check, check.
Yeah.
That was definitely a tricky one.
Oh,
Good thing it wasn't odd, I suppose. Alright. 15. Okay, 15 directions change to positive exponents only. So if we get a negative exponent, we're gonna flip it. Where are we at? Eli. So I see no exponent on the parentheses, so we don't have to worry about that. So we're ready to go ahead and multiply. 5 times -3. -15, but this is Eli's problem.
Oh, sorry.
And then Eli, x -3 times x -3.
Is -6.
X -6. So they did say no exponents, so x6 is going on the bottom. And then y2 times y,
Y3.
y3
Goes on the top.
stays on top. And then z4 times z -5.
Is Z -1 plus 6
So z on the bottom. Okay, number 17. Caden.
Oh, okay.
So for the -2 to the -2, This always confuses people. So let's think of it like this first. Let's pretend that was just a negative 2 squared. What would that be? 4. Negative 2 times negative 2 is 4. Now what happens though when I add that negative exponent in? No. 1 over 4. Flips it. Flips it, right? So this is one of, you could kind of cheat with this. How can we cheat with this? Calculator, because this is just numbers. But it is, your calculator might spit out 0.25, but we want the 1 over 4 answer. So 1 over 4. Hold on, I lost my place. A cubed to the negative, a to the third to the negative 2 would be what?
8 to the 6. Let that be on the
A to the negative 6, so a to the 6 on the bottom. And then b to the negative 5th to the negative 2nd.
B to the 10.
B to the 10th, so that would stay on top. Instead of putting 1 b to the 10th on top, I'm just going to put b to the 10th on top. Because 1 times b to the 10th is just b to the 10th. Alright, we probably better talk about 18 because that'll confuse everybody. 18 says, use the formula v equals 1/3 pi r squared h. Guess what v stands for?
Volume.
Volume. Guess what r stands for?
Radius.
Radius. H,
Height.
height. Okay, this is the volume. They tell you later in the problem that this is the volume formula for a cone. So you guys are gonna have to like learn to do this stuff. Oops, I put 1/2. I did that last time too.
Man, I want to go to Chick-fil-A.
That should have been 1/3, my bad. Okay, then it says that represents volume of the cone with a radius of AB cubed. So they want us to put AB cubed in for the radius. So where the R was, I'm going to put in AB cubed. You guys see what I did there? Where R was, I put in AB cubed.
This isn't gonna be
It's
on
supposed to be
test,
squared.
right?
I do want you guys to be able to do this. I'm not sure I don't remember what's on the test. Okay, the H, it says the height is 6b over A. So where the H was, I'm just going to put 6b over A. So all I did was replace the R and the H so far. But we are going to simplify this. Let's start with the parentheses. Anna, what would the parentheses become? A to the what? Okay. Only B is cubed. Only B is cubed, not A. So it's A to the what? Yeah, A squared, and then it's B to the... What do we do with the exponents there? Huh? Multiply. Power to a power is multiplied, so it's B to the 6. You can think of this A to the as A to the 1, so it's like 1 times 2, but basically it's just A squared. Okay. Now, this is kind of a mess, so what I'm going to do, because we got some fractions in here and some not fractions, I'm going to turn everything into a fraction. So I'm going to put this as A squared B6 over 1. 6b over A, it's already a fraction. Pi is like pi over 1, right? And then if I multiply that to the 1/3, it becomes 1 times pi is pi, 3 times 1 is 3. Okay, let's remember when you multiply a bunch of fractions together, basically all the top, it becomes one giant fraction, basically. All the tops get multiplied together, all the bottoms get multiplied together. It's just like all this over all this. I'm going to start with the normal numbers. I see a 6 over a 3. So what's that going to become? 2. And that's just going to be on top. 6 divided by 3 is 2. Okay, we got rid of that. And then, okay, I see a pi out there by himself, so it's going to stay pi there. And then, I guess we'll go in alphabetical order. A, 2, and then I see an A on the bottom. What's A squared divided by A? A. It's on top 2. And then I see a B6 times a B. B7. So actually it looks like nothing was on the bottom, so we don't really need a fraction.
Let's go.
That was probably like the weirdest one.
Mm-hmm. Okay, 19. Macy, do you remember scientific notation?
No.
Okay, on scientific notation, the rules were put the decimal after the first non-zero digit. You guys remember that?
Yeah. Oh, yeah.
So it becomes 3.19. And what do we always write right after that?
Times 10 to the something.
Times 10 to the something. We got to figure out the something. So it was 0.000319. So how many places did we move the decimal to get it right there? 2, 3, 4. Right. Because we're doing a small decimal number, we need to make that a negative exponent. Negative 4. If it's a big number like 3 million or 3 billion or something, that would be a positive exponent. Number 20, when you multiply 0.0032 times 10 to the 8th into standard, change it to a normal number. You guys, there's a couple ways we could do it. Does anybody have an idea for 20? Move the decimal over to the right 8 times. Every time you multiply by 10, it moves the decimal to the right once. The number gets bigger and bigger and bigger. So it's 8 decimal moves to the right. There's another way we could do it. And that would be plug it in the calculator, because we just want a normal number on that one. Okay, 21. Division. Do you guys remember how we did this? Basically, we just divided the parts on 21. So you can do 9 divided by 3 is 3. And then 10 divided by 10 to the 8th divided by 10 to the 3rd. What would that be? AC, what would this be?
What would, what, the 10 to the, what? Oh, 10 to the 4th.
10 to the 5th. Okay. Is this in scientific notation?
Yeah.
Yes. Because the decimal's right there, so that's fine. So we're done with that one. Okay, 23. It says 5 times 10 to the 4th to the 3rd. Okay, so we just need to cube all of this. Do you guys remember what 5 cubed
125.
was? 125. If you forget, you just gotta plug it in the calculator. Well, you can do it by hand, but plug it in the calculator. And then what's 10 to the 4th to the 3rd?
12.
Times 10 to the 12th. Is this in scientific notation?
No.
No. What's wrong?
Yeah, that's with the decimal.
The decimal should be right there. Okay, you guys remember the trick? So the decimal used to be right here. So I moved it 2 this way. Was I making the number, did I make the number get smaller or bigger? Smaller. If I make this number 2 moves smaller, what do I do to the exponent?
Make it bigger.
Make it 2 moves bigger. So 12 plus 2 is 14. Okay, way back when we did this assignment, it's been so long because of the snow stuff, but I said that there's kind of a cheating way to do these problems if this confuses you. You guys remember what it was?
Use your calculator.
Put it all in the calculator. The calculator might not give you the right answer. The calculator might say like, just make something up. Let's say the calculator tells us this or something. Why is that not the right answer? Not in scientific notation. So you can plug it all in the calculator, but you still might need to change it into scientific notation. So this would be like 2.3 times 10 to the 6th. So you still have to do some work, maybe, but if you get confused on doing it the other way, that's what you need to do. 23, we just did that one, 1.25 times 14. And then 25.
Wait, what was it? It was 1.25 times x. I was at 14.
Yeah.
I thought it was
25 says plus. Okay, 24 and 25 are adding and subtracting. That's actually the hardest kind of problems on these problems. You can only add and subtract like terms. So if they're both like 10 to the third, 10 to the third, you can add those together. Unfortunately, on 25 and 24, they are not like terms. Again, if this confuses you, just put it in your calculator, hit equals, and then fix it. But here's how you would do it without a calculator. I'm just copying it down right now. Okay, these are not like terms, so we can't really add them together right now. What I would do is I would turn this into a -2. So I made that 1 step bigger. So I'd have to make this 1 step smaller. So it's 0.4 times 10 to the -2. Now that they are like terms, it's kind of like terms, remember, is like 0.4x plus 5x, that would equal like 5.4x. So 0.4 of these plus 5 of these. What's 5 plus 0.4? Always crack. What's 5 plus 0.4? 5.4. So it's 5.4 of these, 10 to the -2. So the answer is 5.4 times 10 to the -2. And that's probably, we're over halfway, so we'll say that's good for today. We're going to finish this tomorrow. Once you guys do the evens, in about 1 minute, I'm going to come around and check your number 2. I think only half the 9th grade got it right on the first try, so see if you guys can beat that.
So we have to soup.
Yes.